Welcome to this introduction to polymerization process part 2. So, in the previous lecture, we studied about different type of a polymeric system classification, and there subsequently we were discussing about the different type of their applications and efficacy through which we can improvise those polymeric products. So, we truncated at the application of thermoplastic polymers. Now, the main thermoplastic polymers which we were discussing that they are using, we may use as industrial wrapping, film, pipe, containers, toys, housewares, etc. And LDP, that is referred as low density polyethylene, they are used in the toy coating, containers, pipe, different type of pallets. These pallets are sometimes used as a supporting materials for various kind of applications, sometimes agricultural films, bags, etc. PVC, it's a very common thing, and all of you are aware about their various application. They are mostly used in the pipe, toys, floorings, etc. So these type of the applications are very common respect to the thermoplastic polymers. Other are like polypropylene. They are very common, used in the automotive part, electrical component, various kind of battery cases, etc. Then PET, they are used in the fibers, bottle, everyone. I mean, if you go for packaged drinking water, if you see the different type of other like juices, etc., you will find their application of the polyethylene terephthalate bottles, food packaging, textile, film, etc. So these are the various spectrum of thermoplastic polymers. Now, why I am telling all of this application, because you can imagine that the wide variety of application of all those polymeric products. Now, the second part of this heat sensitive polymer is to the thermosetting polymers. Now, these thermoset polymers melt only the first time when they are heated, and during the first heating of the polymer they are usually cured. After this, they are not having the tendency to melt. Therefore, the reheating or degradation of these particular polymers are often is very difficult or practically impossible. Some of the examples of these thermoset polymers, you can see the polyurethanes, epoxy, phenolic resins, and if you see that these are some of the applications or products attributed to the thermoset polymers. Let us have a look about the various application of a thermoset polymers. Like epoxy resins, they are the example of applications in the sports equipments, boats, adhesive, automotive components, etc. Now, the polyurethane is again the best example of thermoset polymers, which is having the wide application in coating, film, packaging, adhesive, automotive parts, home appliances, sealant, paint, composite sheets, etc. Now, sometimes you may encounter the joining of various adhesive epoxies. Now, if you see that there are two type of things, one is the epoxy and other one is hardener, and if you combine them, then you can seal anything. That is the best example of a thermosetting polymers, because once you join and after certain period of time they get cured and then they form a hard surface. This is the best example of thermoset polymer. The phenolic resin, they are also known as bakelite. Bakelite is again very common, that is being used in various household appliances, molding, electrical components, automotive parts, etc. So, this bakelite was first invented by Dr. Leo in 1907, and based on the various applications, still this bakelite is being used in various day-to-day affairs. Now, third, which we are discussing about the classification scheme when we were discussing, that is based on the structure of polymers. Now, as an engineering perspective, as a science perspective, this is the most scientific approach of classification of these polymers. So, on this particular basis, the different type of monomers, maybe bifunctional, trifunctional, unsaturation present in the various kind of molecules like double and triple bond, they are used in the polymeric structure. So, usually based on this particular approach, they are divided into three different types: linear, branched and the cross-linked. Now, before we go into the detail of these kind of sub-classification, the purpose of classification is that you are having the different basket, and if you require any kind of different product or any kind of a different property, you can pick that particular thing from that particular basket. So, you are having the third basket, that is based on the structure of polymer, and you are having sub containers in it like linear polymer, branched polymer and a cross-linked polymer. So, we will discuss this thing into the broad spectrum. Now, linear polymers in which the monomer molecules having the functionality greater than 2, they were linked together to form a polymeric molecules either in a one continuous length. These polymers which after the process they are obtained, thus obtained, they are termed as the linear polymer. Now, here you see that we discussed about the polymerization of a polyethylene. Now, these are the building blocks which we were discussing in the first lecture. These are the building blocks, yeah, or you can say that these are the ethylene blocks, and they are joined together to form this particular chain. Now, this is the linear chain. Now, see, since we are at the beginning, you see that when we try to develop this particular linear polymer chain, now here you can see that there must be certain things which need to be applied over here between these two molecules, so that they can join together. We will discuss this particular process because this is the ultimate theme of this particular course, that is a polymerization process. Because ultimately what you require, that you are forming a chain, it should not break until it achieves to the desired application. So, that is the, you can say, the heart of this particular polymerization process. Now, to be more practical, you see that the example of a formation of a polystyrene, we discussed that it offers a wide spectrum of properties. Now, this is a styrene monomer or styrene molecule. Through polymerization, it forms the polystyrene. Now, you see that these are the building blocks, or sometimes referred as a repeating unit, and here you see that this is the double bond which I discussed in the previous lecture. They must have at least either functionality or a double triple bond, so that they can, because see, saturation is the most stable structure. It will be difficult to create these kind of things with a saturated one. So, this type of unsaturation offers a very good route for the development of such kind of a polymeric product. Now, here which I already discussed in the previous lecture, that is the formation of a polyvinyl chloride. Now, another sub basket of this basket is the branched polymer. The branched polymer molecules, they are ones in which the side branches, if you see that these are the side branches, the side branches of are connected with the help of a various monomeric molecules and protruding along with the main polymer chain. Now, this is you can say the main polymeric chain, and here you see that there are various branched molecules are attached, right. Now, here again in the engineering perspective, one thing is important, that the affinity between these two similar type of molecules and affinity of this one in the similar type of molecule, these things are extremely important. Important in the perspective that once you apply to a various industrial application, then they do not offer the detachment. That is why this particular polymer reaction engineering came into existence. Now, to form such kind of a polymer, the monomer must have a capability to grow in more than two directions, like see here 1, 2. Now, it must have an ability to grow in more than two directions. Hence, the monomer used must have a functionality of either two, which we discussed in the very first slide of this branched polymer. So, sometimes it results in the H shape or combed shape of polymers. So, once we intend to develop this branch polymer, and sometimes for a very specific application and sometimes for other kind of a property oriented things, we may require H shape or a comb shape polymer during this polymerization process. So, because this particular approach will be useful in the subsequent studies of this particular course, so let me introduce that what are those H shaped and comb shaped polymers. So, sometimes the branch polymers, they are just like, there are some branches. I will give you some photographs too of this particular branch type. And here you see that there are various repeating units like this. And when we talk about the H shaped, because for specific reasons sometimes you may require or you may need to alter those polymerization process with the help of a certain catalyst, certain pressure temperature conditions. So, these H shaped polymers are just like this, and here you may have a different repeating units like this. This is your H shaped branched polymers. This is the simple branch polymer. Sometimes in various applications you may require the comb shaped one. So, these are the some you can say the comb shaped polymers. These are not a straight one, but like this, and again you may have a different repeating units or monomeric units in a more scientific term. So, these are the comb shaped. So, you can see that by a simple alteration, or sometimes you may say that they offer a various kind of shapes in this particular branch shapes, or you can say sometimes you are creating the n number of different sub baskets within this branched polymers. Now, one of the best example which we discussed about the LDPE or high density polyethylene or a linear low density polyethylene. Now, we are discussing that there are three different type of polyethylenes: low density polyethylene, high density polyethylene, and a linear low density polyethylene. So, the monomer for each kind of polymer is ethylene. Now, we can form different type of polymeric product by the application of a various polymerization protocol, maybe like this, that HDPE, then LDPE or LLDPE. Now, you see that there are comb like structure, there are H type of structure, and there are a linear type of structure. So, if you see that based on the requirement, based on the properties you are looking for, you can develop different kind of polymers with the same type of monomer. Here the monomer is same, that is ethylene, but you are having low density polyethylene, high density polyethylene, linear low density polyethylene. So, based on the requirement you can develop the protocol. Again, when you are developing the different type of a system for the development of a different type of the polymer, you require special attention of reaction engineering, because a slight change in the temperature, slight change in the concentration, slight change in the pressure thing may change the ultimate product drastically. So, that is why the major impetus towards we focus towards the basic theory, towards the engineering perspective. Now, come to the last basket or last sub basket of the third basket, that is the cross-linked polymer. Now, this cross-linked polymer, if you see in this particular figure, the things are linked together in a compact form. The polymer molecules link together with each other or other molecules irrespective of to the end functional group in the structure of polymer. They are termed as a cross-linked polymer, and generally the trifunctional molecules or monomers are used in the synthesis of a cross-linked polymer. One best part of these cross-linked polymer is that they offer good mechanical strength, because the polymeric chains are intermingled like this, and they are not only linked with the monomers in a one side, they may link with the couple of other sides too. So, if you are looking for more and more mechanical strength and more you can say the thermal strength, then this particular sub basket offers a wide spectrum, wide opportunity. One best example is that if you see the polymeric beads which are used for ion exchange resins in your different type of wastewater applications, you see that these beads are the best example of a cross-linking polymers. Now, as we go into the detail of this cross-linked polymer, and as I told you that they are linked together with each other to form the different type of things, and as per this particular photograph, you see that they are linked together. To more simplify the things, now to give a brief input or give you a skeleton type of approach for this cross-linked polymer. Now you can see that there are different approaches like this. Here you can have this type of thing. Now here this is the different repeating units. I will give you an example of bakelite. So the different monomeric units, and they are combined together with the form of this cross-linked polymer. So these are the small monomeric units or repeating units. So this is the example of cross-linked polymer. Now see, when we have this type of structure, it is quite implicated that this particular structure offers more and more mechanical strength. But simultaneously when we are knitting together or when we are forming this type of a cross linking with the help of a different covalent bond, different bonding structure, etc., then they offer some sort of a minimum flexibility. And that is why if you go to the first slide of this cross linking approach, then at the time of formation of this cross link polymer, only then you can form the structure or the application oriented objects. After curing, it is extremely difficult to reorient the object or reorient the product by a simple application of heat or any other process conditions. So that is why, because of this type of a thing, because of this type of a close bondness, it is extremely difficult to change the structure, change the product morphology after the curing. And that is why they offer very good approach, but sometimes their recycling is extremely difficult. You just see, when you used to discard your used switches, then you are not having any option to either recycle or remelt into the different products. Now they may vary in the structure to obtain the light cross linking, like rubber like cross linking provides the elastic properties. Best example is your automotive tire, or highly cross linked polymer to provide the high rigidity, because I told you that sometimes they are just like attached to each other in just like this particular approach. So they offer the high rigidity, they offer the high structural stability like in phenol or a urea formaldehyde, and sometimes you may see that your domestic switches, electrical switches, they are also the best example of your cross-linked polymer. So based on the variety, based on the requirement, you can develop these kind of cross-linked polymers. Another example is that your bakelite, which we were discussing about, that you see that they are the heavy molecules and they are linked together with the help of this linking agent. So, sometimes phenol formaldehyde, this is again the best type of a thermoset polymer, bakelite, which is sometimes referred as a bakelite. So, based on this particular requirement, either the flexibility or you can say the stiffness, or you can say the environmental resistance approach, you can develop these kind of various polymers. And this particular approach, that is the classification approach with respect to the linear, branched and cross-link, they offer a wide spectrum of choices available to you. Now, one major emphasis which I would like to give at the end of this particular chapter is that everywhere when we talk about the polymer, nowadays two things should come into our mind. One is that what is the requirement, that is the based on the couple of things like energy efficient process, eco-friendly, and above all it needs to fulfill the requirement of either mankind or industrial application. Now, based on this particular requirement, you can choose the appropriate classification term, and once you choose this appropriate classification stream, then you can choose the appropriate monomer, you can adopt the different polymerization processes, etc. Now, when we conclude this particular lecture, because if you see that in last two lectures we discussed the wide spectrum and wide variety of a product profile of these polymeric product. So, based on the requirement, and if you see that they offer the flexibility to the stiffness, they are present in the form of a naturally occurring polymer to the synthetic one. Based on the other applications, every time people try to develop a new and new polymerization processes and different theories, different modeling streams, etc. So, in the next lecture, we will discuss a brief history about these polymerization processes, so that you can acquainted with that what kind of the things people were looking for in the past, and it gives you an out of a box thinking that how they approach to the desired product. Thank you very much.